Alright guys, here's the review for section 2.5 to 2.8. The first three is just determining the correlation of the points on the graph. In this case, the points here are all over the place. There's no really set line I can draw through them. So in that case, the answer is going to be no correlation. Here, these are all moving in what I would consider a positive slope fashion. So in that case, the answer is a positive correlation. And here, we would be moving in a negative slope fashion, such as this, based on this line. So my answer here would be negative correlation. So those are the top three. Okay. Now, you'll get something like this on the test as well, where I'm going to have you sketch the graph, but you're also going to find the equation of the line through Desmos. So our first step here is just to graph the points. So if we can, yikes, get out of that. Okay, get to here. Okay, so 10:15 is right about here. And then 12:20 would be about here. 14:24 would be about here. 15:24 would be here. 15:28 would be somewhere around there. 17:32 would be right about here. 18:31, I would argue somewhere right around here, and 19:33 would be right here. And if you notice, the type of line I would get as a best fit would look something like this. But to be exact, what we're going to do is we're going to go to Desmos, and we're going to put those points in. Okay, so we're going to go to our graphing calculator. We're going to go to table, and now I need to put those points in. So it's 10, 12, 14, 15. 10, 12, 14, 15. And then 15, 17, 18, 19. 15, 17, 18, and 19. And then we put our y's in. And our y's are going to be 15, 20, 24, 24. So 15, 20, 24, 24. And then 28, 32, 31, 33. 28, 32, 31, 33. And then we're going to go to number 2, and we're going to draw y1, squiggly line, mx1 plus b. And notice the r is 0.97. So if the r is 0.97, okay, that's our r. R is 0.97. That's a strong positive correlation. And then the equation of my line here, I'm just reading it off my graphing calculator. My slope is 2.03 and my y-intercept is negative 4.59. So y equals 2.03x minus 4.59. And those numbers are coming straight from my graphing calculator Desmos my Desmos website. Okay. So that's how we do line of best fit. Okay, and what I'll ask for on the test. All right, now we're going to go to graphing an absolute value. And really, we're just going to work off of the XY chart. And we always start, we're going to put this together so I can always kind of, we're going to group it, and we're going to copy it. Okay, so I always start with my vertex. So my vertex is going to be 1, 7. Remember, we changed the sign of the x, we keep the sign of the y. So the vertex is 1, 7. And then I want to pick 1x below it and 1x above it. So when I plug 0 in for x, 0 minus 1, negative 1, the absolute value of negative 1 is 1. 1 times negative 2 is negative 2, and negative 2 plus 7 gives me 5. And then the other side should also give me 5, because these are symmetric. 2 minus 1 is 1, absolute value of 1 is 1, 1 times negative 2 is negative 2, and negative 2 plus 7 is also 5. And now we're going to graph it. We're going to go 1, 7, 1, 2, 3, 4, 5, 6, 7, and we're at 0, 5, and 2, 5. So now I go to graph it. This is what my graph is going to look like. It will look like a V going downward. We always want to put the arrows there. Oops. So we know it's going down to infinity. Alright, clone this, put this chart over, put it up here. Okay. Now my vertex right away, change the x sign, negative 1, keep the y sign of the vertex at the negative 2. And I'm getting that from the 1 here and the negative 2. Negative 1 makes the absolute value equal to 0. The negative 2 out here is your y coordinate for the vertex. And now I'm going to pick a number that 1/2 works well with. So instead I'm going to go with negative 3. Because negative 3 plus 1 is negative 2. The absolute value of negative 2 is 2. 2 times 1/2 is 1. And 1 minus 2 is negative 1. And going 2 more on the other side, we get 1. That's also going to give us... Okay, let me just move these lines here. They are in mistake, so let me just fix that. Sorry about that. Okay, I'll get these lines off. Okay, so now when I go to graph this, alright, this graph is going to be negative 1, negative 2, so I'm here. We're going negative 3, negative 1, so we're going here. And we're going 1, negative 1, so we're going here. So this should open upward, and if you notice that 1/2 in front makes it open much, much wider. Okay? When the number in front of the absolute value is less than 1, greater than negative 1, in that range, the graph opens much wider. When the A is either bigger than 1 or less than negative 1, it's a much more narrow opening, and it goes down or up a lot quicker. So just be aware of that. Okay. The next one here, and oops. Okay, sorry about that. So now for the next two, I'm going to clone, bring this down here, clone, and bring this over here. We're going to bring our grass here. Here we go. Okay, so here, once again, my vertex, negative 2, negative 8. And then I'm going to pick a number below it and a number above it. So I'm going to go with negative 3. Negative 3 plus 2 is negative 1. Negative 1 is, absolute value of negative 1 is 1. 1 times 4 is 4. 4 minus 8 is negative 4. Down here, we're going to go with negative 1. Negative 1 plus 2 is positive 1. The absolute value of 1 is 1. 1 times 4 is 4. And 4 minus 8 is negative 4. So my graph comes from here. So I'm going to plot negative 3, negative 4. 1, 2, 3, 4. I'm going to plot negative 2, negative 8. Negative 2, 1, 2, 3. Negative 8, and then negative 1, negative 4 is right here. And you notice when that number in front of the absolute value is big, it causes the graph to go up very quickly. We call it vertical stretch and horizontal shrink. When there's a fraction less than 1, but greater than negative 1, in front of the absolute value, that represents horizontal stretch, and vertical shrink, it's like this one up here, makes the graph go out wider. Alright, last one on this page, my vertex is going to be 3, 2. Okay, now if it's 3, 2, I want to pick numbers that can work with the negative 1/3. So I'm going to use 0, and I'm going to use 6. 0 minus 3 is negative 3. The absolute value of negative 3 is 3. 3 times negative 1/3 is negative 1. Negative 1 plus 2 is 1. And then 6 minus 3 is 3. 3 times negative 1/3 is negative 1. Negative 1 plus 2 is 1. So now, 3, 2, and we're going 0, 1, and we're going 6, 1. And once again, that graph will look like this. It opens out very wide. Okay, so when that number in front of the absolute value is between negative 1 and 1, we have horizontal stretch, vertical shrink. When the number in front of the absolute value is either greater than 1 or less than negative 1, we have vertical stretch and horizontal shrink, and that graph opens up or down very quickly.